Mass spectrometry is a experimental technique in which scientists can determine the number of isotopes that an element has and their relative abundance utilizing the following technique as you see here. So what would happen is you would put in any type of mass spectrometry is mainly used with elements, and it can be used for other things too, like compounds and such. But for the sake of AP chemistry, what you'll do is you'll put your sample in here. So let's say in this case, I think they're doing one which is on zirconium. So they're doing zirconium. So you put a sample of zirconium element, something you mine from the ground, let's say, and put in a sample. You run through this machine, and the key thing is you'll notice that the magnet, as isotopes pass through and they enter the magnet, they will be deflected by the magnet. Now you'll notice that from here, this line right here is deflected the most by the magnet. This isotope is deflected the least. The first question I would have for you is, which would be deflected the most or least? The element, the isotope that is the heaviest or the lightest? What do you think? The element, the isotope that is deflected the most has to be the lightest because it'll be the easiest to change its path. Those that are heavier will not deflect as much because of their inertia. Their more mass, it has more inertia. It's a physics concept, and therefore we're able to separate the individual isotopes based on their relative size because of how much they deflect. The analyzer then determines how many of each is present throughout the sample, and from that we can gather, let me check to make sure, the following data, which we can see right here. What you'll see in a mass spectrometry problem is you're going to see these little spikes on this graph, and each of the spikes is a different isotope. So this one right here is the zirconium-90 isotope. This is zirconium-94. This is 96. And if you look at these isotopes here, what's all the same about all of these isotopes? What is a similarity that they all have? Well, if they're all the element zirconium, they all have the same number of protons. So the number of protons would be the same in all of them. What's different, and there also probably be electrons because more than likely these are going to be atoms of zirconium. What's different is the number of neutrons. Each peak, the difference in them is they have more or less neutrons. Zirconium-91 has one more neutron than zirconium-90, okay, and so on and so forth. So from this information, we're able to figure out how many isotopes we have, what their masses are, and then the relative height tells me their relative abundance. Okay, and actually this is incorrect. It really shouldn't say relative because it's a percentage. This is actually a percent abundance. So typically in the graph, you're going to be given the percent abundance of each isotope, how many there are, and what their masses are. So from here, we'd estimate that it's a little bit above 50. So maybe we would say this is around 51% zirconium-90. Then the next one here at 91 looks like it's a little bit above 10. So again, maybe we say it's about 11% zirconium-91. Then at 92, this looks like it's a little bit below the 20 mine. I'm going to estimate it about 17% zirconium-92. The next one, they look like they're about the same. Maybe it's just a little bit higher. So maybe I'll go to 18% zirconium-94. And then 96, that looks to be about, it's not quite halfway. I'm going to say about 3% zirconium-96. Now, if I did an accurate job of determining all these isotopes, what should all these percentages add up to? They should be 100% because of the sample. These are all the naturally occurring isotopes of zirconium, and therefore, out of every 100 particles, 51 of every 100 particles will be zirconium-90, and so on and so forth. Well, if I go ahead and add this together, what do I get? 51 plus 11 plus 17 plus 18 plus 3 That adds up to, looks like that's 20, carry the 1, 7, 8, 9, 10. Comes out perfectly 100%. Now, these percentages might be a little bit off for each of them. Maybe they're within 1, maybe 2. But overall, when I end up doing this problem, because I'm at 100%, I know that when I do the atomic mass problem for this value, I'm going to come to with an atomic mass of zirconium that's very close to what you'll find in the periodic table. So again, 51%. How would we figure out the atomic mass of zirconium? We'd first have to move the decimal point to the left 2 times for each of these. Okay, we'd take 0.51, we'd multiply it by 90. Okay, we'd take 0.11 times 91 and so on and so forth. We'd do this for all of the 5 isotopes. We'd add up all these numbers, and what we get then is the atomic mass of zirconium, which should match what's on the periodic table. So the main thing from today is just understand that mass spectrometry is just a technique that scientists utilize in order to gather information about the isotopes of elements to figure out how many naturally occurring isotopes each element has, what their percent abundances are of each of those, and that information then can be utilized to calculate the atomic mass of each of the elements. Okay, I do have a short other video that you can watch in mass spectrometry, which might go in a little more depth than what I have. You can gladly watch it if you so choose. I believe it's from Bozeman Science. And then the homework is the next page in the packet. In the packet, there's another problem set. There's not a problem set. There's another. The next page is about 4 or 5 problems using mass spectrometry, graphs that you see here, and answering questions off of them. All right. So do that homework set. I again will have an answer key online that you can check. And now that you've gone through all of this work, I now will have a homework in Pearson that I'll assign for next week for you to work on. These homeworks again are just introductory homeworks, getting you through the content, see how well you understood the video, and then you can do the graded homework that will count and be placed into your grades. If you have any questions, come see me, please. Thank you.